Hi students, this is Saheb sir, your chemistry mentor. Today we are going to learn about orbit, orbital and nodal space. First of all, we are learning about orbit and orbital, the differences between orbit and orbital, definition and their characteristics. Okay, first of all, what is orbit? What is orbit? We know that around the nucleus, the electron rotating fixed path around the nucleus, the electron rotating fixed path known as orbit. Around the nucleus, the electron rotating fixed path known as orbit. And what is orbital? What is orbital? The orbital is the electron binding place. Electron binding place. The three-dimensional space. The three-dimensional space around the nucleus where the probability of finding electrons is maximum, that is nearly 95%, known as orbital. Okay students, next, what is nodal space? Just we discuss definition, later we discuss later part. Okay, what is nodal space? Where the finding of maximum electrons is known as orbital around the nucleus, but here is zero, the electrons not containing place, the electrons not binding place is known as nodal space. Same definition, but here is maximum, here is zero. The three-dimensional space, around the nucleus where the probability of finding electrons is zero or minimum, known as nodal space. Okay students, these are the definitions of orbit, orbital and nodal space. Orbit is electron rotating path. This is the path. What is orbital? Electrons are more binding space. Where electrons are more in cloud, that electron clouds are known as orbitals. Where electrons are finding zero, that is nodal space. Okay students? Okay students, we are going to next points. Orbit, what represents? It represents the movement of electron in one path. Movement of electron in one path. In the orbital, what represents? It represents the three-dimensional shapes of the electrons. It is only one path. It is three-dimensional shapes of or space of electrons. Okay, next. Number of electrons found in orbit is 2n square. N is equal to orbits. N is equal to 1, 2, 3 or K, L, M. Like that. In 1 square, 2n square, 2 electrons are found. Like that, 2n square formula is useful for number of electrons finding in orbits. First orbit, second orbit, third orbit, like that. Okay. Here orbital number of electrons is always 2 electrons fixed. Px, Py, Pz. Px has 2 electrons. Py has 2 electrons. Pz has 2 electrons. Like that s orbital has 2 electrons. Like orbital always has only 2 electrons with 2 different signs, that is positive sign and negative sign according to spin quantum number. Next, it's the orbits are circular in shape. Circular in shape, always circular in shape around the nucleus, like this. Around the nucleus, the shapes of the orbits are always circular. That is the paths of electrons movements. Next, different shapes are present. S orbital has spherical shape. P orbital has dumbbell shape. D orbital has double dumbbell shape. F orbital has no specific shape. Here shown this blue color lines, blue color circle is the S orbital. It occupies around the nucleus total space. Around the nucleus three-dimensionally total space like ball. Okay, this is the S orbital. This dumbbell shape is the px orbital. Here is between the axes. Between the one main difference, p orbital placed in the axis, that is x-axis, y-axis or z-axis. But here x square, dx square, y square orbitals, d orbitals always occupies between the axis. Between the axis places. Okay, this is the double dumbbell, this is the dumbbell, this is the spherical shape. Orbit have no direction, not directional, but except s orbital, all orbital are directional, that is x-axis, y, z-axis, that is the directions of their orbitals. Except s orbital, remaining 3 orbitals are directional. Okay, and electrons position and velocity can be known by certainty in orbit. In orbit, we can find the position and velocity of an electron by certainty. Not accurately, but certainly we can find the position and velocity of an electron. In this orbital, position and velocity of an electron can be finding by certainty is not possible. In orbit, it is possible by certainty, but in orbital, it is not possible. This is the orbit and orbital main differences. Very important. Please note down. With pause the video. Next, what is next? Nodal space. We know that the zero finding probability of electrons around the nucleus in 3-dimensionally is known as nodal space. Zero probability. There is no electrons where around the nucleus. That space is known as nodal space. Okay, these nodal spaces are 2 types: radial nodal space and angular nodes. Okay, for finding the number of nodes, for radial nodes, that is n minus L minus 1, that is principal quantum number minus azimuthal quantum number minus 1. Where finding of angular nodes, number of angular nodes, that is L, only azimuthal quantum number is equal to angular nodes number. Next, total nodes in an atom is the n minus 1, principal quantum number minus 1. Take one example like 3p1 electron. This 3p1 electron has radial nodes n minus L minus 1. What is n? This 3 is n. What is the L value of p? Always 1. That is 1. 3 minus 1 minus 1. 3 minus 1, 2. 2 minus 1, 1. So radial nodes are 1. Angular nodes always equal to azimuthal quantum number. That is L value of p is 1. That is 1. And total nodes, how can we find? Principal quantum number minus 1. What is the principal quantum number here? 3. 3 minus 1, that is 3 minus 1. That is total number of nodes is in 3p or 3p1 orbital is 2. Okay students, this is very important. Finding the nodes in EAMCET and competitive exams, and in intermediate IP purpose, orbit and orbital is the very important. Please pause the video and note down the video. Thank you.